Hey guys, I'm not here. I am out at a meeting, so I wanted to continue the lesson on hyperbolas. Before we do that though, let's go ahead and take a look at these four equations and see if you can identify what they are without having to put them in standard form. Okay, so remember what I talked about. Identify which letters are squared. Number one, we can see that both x and y are squared. Also identify if they are adding or subtracting. Well, this one's adding, but so that's either going to be a circle or an ellipse. However, there's a coefficient in front of x squared and y squared. So this one is an ellipse. Number two, what letter is squared? Only one, which is your x is squared. That's a parabola. Number three, x squared and y squared or x and y are squared. However, it's subtracting. This one's a hyperbola. If you hear my kids in the background, that's because they're here with me. Mommy's got to do what a mommy's got to do. Okay, number four. Both the x and the y are squared. They're adding. There's no coefficients in front of the x squared and y squared. So this one is a circle. Number four. You don't have to write these down. I just want you guys to be able to verify those. Your worksheet today, it's a mixture. Help each other out to identify which one's which before you leave. And hopefully you guys can do that at the second part of the video here, second part of the period. All right, let's go ahead and get started and do hyperbolas. So a hyperbola is, they look like a set of two parabolas, but they don't have the same properties as I have it here. It actually curves more approaching the asymptote. So they're not really parabolas. They look like parabolas, but they don't have the same characteristics as a parabola. At any time, if you guys need to stop, ask the sub if they can pause the video, or somebody just go up and pause it, and then we can start. All right. So a hyperbola can open two different ways, depending which variable is positive. In this equation here, if your x is in front, if it's positive, then it will have a horizontal transverse axis. It's kind of like the major axis from the ellipse. If it was remember if it was a major axis that was horizontal, then it was elongated horizontally. Well, hyperbola, if the x is in the front and the y is negative, then it has a horizontal transverse axis, and the hyperbola will open left and right. Notice that there's asymptotes to this hyperbola. It's the only conic section that has asymptotes. The circle, ellipse, and parabola do not. You do not need to write the equation for the asymptote. I will show you how these asymptotes are created using A and B. But you don't need to write the equation to the asymptote. We're not going to focus on the equation for the asymptote. Just be able to sketch it. Again, if x is in the front, x being squared, it's a horizontal transverse axis. That one you do need to write. I get these three stars here. Your center, as all the other conics, are at HK. Okay, now if y is in the front and x is negative, then it has a vertical transverse axis. Therefore, your hyperbola will open up and down. Again, you have your asymptotes there. Okay, again, if you guys need to stop the video, go ahead and stop at any time. Let's go on. Let's go ahead and graph. Oh, I'm sorry, before we graph, Um, so a couple of tips. I talked about this last week when we were talking about ellipse and circles. H and x, though, they will always be together. So x minus h, as you've seen in all our equations, x minus h squared plus y will always be with k. Remember, that was for our circle, and the same thing applies to the ellipse. Same thing applies for the hyperbola. So h and x will always be together, k and y will always be together. If x is first, it's going to open left and right. If y is first, then it's going to open up or down. So it depends on who is negative. If x is first, then I'll say x squared minus y squared. So it's going to open left and right. If it's y first, it'll be y squared minus x squared. Then it'll open up and down. This one's different compared to that of an ellipse. A is always the first denominator, whether x would be first or y first. So A is that first denominator. And then we're going to use the slope y over x, which is, it comes from your A and B. Okay. How to graph it? What we're going to do, you have to identify first if it opens up and down or left and right. Find the center just like we've been doing with HK. And graph, what I mean by that is just plot it. Plot the center. Find your AB, and you're going to use that just like you did with the ellipse. Your A, depending on if x is first, you move left and right. Your B, you would go up and down. Using A and B, you're going to draw a rectangle, and then plot your vertices. You're going to connect one corner to the other, like crisscross, to make your asymptotes. Let me show you what I'm talking about. This one. Okay, so your center is at -3, 2. First of all, x is first. So how is that? That's going to open left and right. Okay, it's going to open left and right. It's important that you guys remember it's not a parabola, so it's going to actually approach the asymptotes. Okay, so -3, 2 is here. The number, the first denominator is your A. Since it's the denominator of your x, then you're going to move left and right 12 units. Because it's under the x, x is horizontal. So you go 12 to the right. And then 12 to the left. That's going to be a long box. And the 25, that's under your y, so that's going to be vertical 5. And up and down 5. Okay, so that's how an ellipse would be graphed. However, this is a hyperbola. You're going to connect these dots by making a rectangle. And I'm going to do dotted because it's not really part of your graph. What it does is it's going to help you find the asymptotes. And when you have the asymptotes, that helps you sketch the graph. Okay, now you're going to make a line that's crisscross. So from corner to corner, and this is, let me move these up a bit. Okay, I'm going to erase that. Okay, from corner to corner. Then, remember, this is a sideways parabola. At the blue points here, which was your A, those are your vertices. So just do a sort of like a sideways parabola see if I can move this over. Okay, so your hyperbola goes like this. Okay, that's your vertex. It's going to curve. Whoops. All right, like that, and it approaches the asymptotes. Okay, same thing on the other side. Please make sure you identify the vertice. The vertice is your A, the number that you want, and that's your hyperbola. That is a beautiful graph. Okay, so let's go ahead and do one that it's not in standard form. Okay, again, just like the ellipse, group all the x's, group all the y's. I'm going to go ahead and move that 72 over. You guys can keep it. We've talked about this. Now, before you guys half and square, please make sure you factor out your A. Otherwise, you cannot half and square that. Okay? Okay, factor out the 9 here. And then remember, you factor it out. Be careful because you factor it out a negative. So negative 72 will become positive 8. Let me write this better. Positive 8 here, 8y. Okay, now go ahead and half and square. When we half and square here, we get 9. We add 9 to the other side, but don't forget we factored out a 4, so you need to multiply by 4. Half of 8 is 4. 4 squared, 16. You add 16 to the other side, and that's times negative 9 because we factored out a negative. Okay, so after we add all this up, we get negative 36. And then your binomial square here is x minus 3 squared. Your binomial square here is y plus 4 squared. And then the very last thing you need to do, just like we did with the ellipse, is make this equal to 1. And by doing that, we divide, in this case, by negative 36. So be careful because what's going to happen here is the instead of the y being negative, because we have negative 9 divided by negative 36, it's going to become positive y over 4, and the x becomes negative. And it's equal to 1. So they swap roles because of the sign change. You always need to put it in standard form, so your positive variable needs to go in the front minus the, minus your other variable. Okay, so when we graph this, again, our center is at negative 4, 3. Okay, our center is at negative 4, 3, which is here. Our A is 2. Remember, A is always going to be your first one in this case. So it's 2. And since it's under y, you're going to go up 2, down 2. Your B is 3. And you're going to go to the right 3 and to the left 3. Again, because B, or 3 in this case, is under your x, and x is always horizontal. Draw a rectangle. Notice I didn't really dash it just because I'm running out of time here. Crisscross through the center. Make sure you go through the center. Your vertices. Oh, what kind of hyperbola will this be? It's up and down because y is positive. Your vertice will be the value when you went up 2, and you just follow the curve, follow the asymptotes, like that. Okay? All right, so hopefully that's enough. If not, repeat the video, look in your book, help each other out, and try to do the problems I left for you on the worksheet. Okay? See you tomorrow.